Okay, let's go ahead and start looking at this problem by duplicating our work for this one to see that we can verify our solutions, and then see how the problem changes for quarterly and monthly, and then of course at the very end compounded daily. So to get started, let's go ahead and first of all look at our formula. Our formula is equal to A, in this particular case, is the total amount in the account after we invest the amount for a particular interest rate for a particular number of years, compounded quarterly, annually, etc. And this goes to our principal, and our principal in our problem was $2,000 times 1 plus our interest rate, which is 0.08, and n is our denominator here, and it is the number of times that we're compounding. Now we're working on this first one, so compounding n would equal 1. So even though that doesn't really, 0.08 divided by 1 is just 0.08, we'll still keep it in there. And then our exponent would come up here then, would be the number of compounding periods times the number of years. And it looks like for here we're using 10 years, so it would be 1 times 10. So go ahead and take a second and plug this into your calculator, and let's see what we get for an answer. Okay, when I plug this in, for this particular case I get 4317.849, but this will round, and so what I get here is 4317.85. Now this matches perfectly with the solution here, so I know I'm using the right formula and I'm in the right process. Now what we want to do is see how this changes when we're working with different compounding periods. So for our next problem, let's go ahead and let's try our quarterly. So for quarterly, we'd have A equal 2,000 times 1 plus my interest rate, 0.08 over 4 now. Last time we compounded annually, and when you compound annually, that n equals 1. But when you compound quarterly, that's n equal 4. And just as a side note, compounding monthly is n equal 12. And compounding daily, that's n equal 365. So that's the value that will change in each of these formulas. Now my exponent is going to be n, the number of compounding periods, which in this case is 4, times t, the number of years, which is 10. So let's go ahead and take a second and plug this into our calculators and see what we get back. And you do need to be careful about how you plug it in, but like I said, once we got that first one to work, all of these should work from here, as long as we plug in the correct values. So when I plug this into my calculator, I have 4416.079. Now we're going to round this up to the nearest cent, so our answer should be then 4416.08, and this is for quarterly. Now the only thing that's going to change on this formula next then for monthly would be n equals 12, and that's going to affect this value will change to 12, and so will this one. Now compounding daily, this value will change to 365, and this exponent will change to 365 times 10. So those are the only things that change in your formula. So just double check your work there, and if you're still stuck, let me know.